Okay, so we're going to have a look at how we draw quadratic graphs. All right, so you're asked to copy out the table of values here, and you'll need the graph, preferably on graph paper, but if not squared paper, making sure that you've got equal spacing between each of the values. We're asked to draw the graph y equals x squared, okay, for the values that include -3 up to 3, and hence they're the values in the table. So this is the easiest type of quadratic graph because it's only got this part that we need to work out, the x squared. And therefore, we can do that by substituting in each of the numbers. So I know y is equal to -3 squared, and we always want to pop it in a bracket. So actually what you do need to be aware of is the fact that whenever you're doing this type of question, I would always put a bracket around the x's, okay, because that's going to remind you where you're going to substitute each of the numbers into. And be careful, because I guarantee there's a few people out there saying that the answer to this is going to be -9, and it's not. -3 squared is -3 multiplied by -3, which will give us +9. Okay, so +9 is going to go in there. For the second one then, I would be doing -2 squared, and remember that's -2 times -2, making +4. I'm then going to calculate -1 squared. That's going to give me +1, and so on. So 0 squared will be 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And then I want to be able to plot my values. Okay, so to plot the values on a quadratic or any graph at this point, we always use a little cross. So a cross is much better. It shows up really nicely and clearly when you're doing an exam paper. Okay, so my x value is -3 and my y value is 9. So I'm going to plot my cross there. And then for the next one, my x value is -2 and my y value is 4. So my coordinate is going to be plotted there. Then I've got -1, 1, 0, 0, 1, 1 again, 2, 4, and 3, 9. Okay, and you should be able to see the shape of the curve here. Now this is where you'll be able to do it much better on paper than I can on screen. It should be one smooth curve that joins all of the points, and it must go through each of the points. So you need to take it nice and slowly. You also need to make sure it's got a curved bottom. Okay, so ideally a little bit better than mine going through that bottom bit there. So I'm actually going to rub that out and make it a little bit tidier. So if I rub out just so that you can see how good it should be when we're doing this one. So it should be a nice, it shouldn't be pointy, so just be really careful with that one. So we're just a nice smooth curve going through and coming back up. Okay, and actually this type of graph with this U shape is called a parabola. Okay, so just get used to seeing and using that word. So that's the posh word for using that U-shaped graph, which is a quadratic graph. All quadratic graphs will have a line of symmetry. Okay, so hopefully for this one, you can see the line of symmetry is actually this line here. All right, so if you could see it showing up there, I'm going to use the highlighter, I think, on this one, just so that you can see a little bit clearer. But this would be my line of symmetry going down here, okay, which is in fact on my y-axis, but the actual equation for that line, so remember it's a line that is crossing the x-axis and going through 0, so the line of symmetry for this particular graph is in fact x equals 0, or the y-axis. All right, so just be mindful of that. It also has what we call a vertex. Okay, so the vertex is the turning point of the graph. So I'm going to pop that down so you can make notes on that one. So the turning point of the graph. And that's basically where does the graph change direction? Well, the graph is coming down here. And at this point here, 0, 0, it changes direction and goes back up again. So that is in fact my vertex. Okay, so we're going to have a look at another question. So this time I'm going to make it slightly more difficult. All right, so again, this is the table of values. We're going to plot the graph -x squared. plus 10. And again, I'm going to pop in that set of brackets just around the x. The only thing in the brackets is my x, and therefore when I'm doing my calculation in a minute, it's going to be y equals minus brackets squared plus 10, which you can use your calculator for doing this. I'll do it for another one as well so that you can see. So therefore, all you need to actually change are the numbers in the calculator within the brackets at that point. So my starting value is going to be minus 3. And if we pop in minus 3 squared in the calculator will give us positive 9. And then that negative outside it will make it minus 9 plus 10. And minus 9 plus 10 will give me 1. So 1 is my first value there. I then substitute in the minus 2 into the bracket. Minus 2 squared is 4. Then that negative outside will make it negative 4. And negative 4 plus 10 will make it 6. And we can carry on, so you can keep going with those. So minus 1 squared will be 1. Put the minus in front of that gives it minus 1. Add 10 gives me 9. And when you work out all of your values, you'll get 10 for 0, 9 for 1, 6 for 2, and 1 for 3. And then again, you need to plot your values for this. So if we're plotting our values, I've got minus 3 along and 1 high. And then minus 2 and 6. And then minus 1 and 9. 0 and 10. 1 and 9. 2 and 6. And 3 and 1. Okay, so I end up with those points, and again you should see it's a nice smooth curve hopefully that we need to draw. Again, it's a parabola, but this time it's upside down. Okay, so the reason it's upside down is because we have a negative x squared graph, so it actually ends up being a reflection. So I'm going to start here just so that you can see how it should be. So remember, one smooth line going through, and we just want to carry it on a bit beyond the coordinates, going through each of the points, making sure it's not pointed, and we end up with that particular graph. And again, we can think about what our line of symmetry will be, and it's symmetrical again about this point. So you can see, I'm just going to go over it here so that you can see the yellow hopefully, but its line of symmetry at that point again is the y-axis or x equals 0 line. It's not always that, so just be mindful of that one. So line of symmetry is therefore x equals 0, and the vertex, the turning point, is this one up here. Okay, so my vertex where the graph changes direction is in fact 0, 10. Okay, so 0 along and 10 high. And we're going to have a look at one more question just to make sure that you are okay with this particular topic. Okay, so we're just making it slightly harder again. This time, wherever there is an x, and there's more than one, this time I'm going to put in the brackets just to show what I'm doing. And this time it's for the values from minus 2 up until 4. So it's y equals brackets squared minus 2 brackets minus 3. Okay, I'll do a couple of them so that you can see. Remember, you can be using a calculator to help you do this. It could come up on a non-calculator exam, but when you get to the slightly more complicated ones, they're often on the calculator. All right, but be prepared to be able to do it for either. And then, if we think about how we would fill this in, it's then going to be minus 2 squared and minus 2 in there. So minus 2 squared will give me 4. Minus 2 times minus 2 will mean I'm adding 4, and then I'm taking away 3 from that. So that will give me 5. Okay, so just be mindful for this one, I would get 5. I do it for the second one, so minus 1 in the brackets. Minus 1 squared is 1. Minus 2 times minus 1 is going to give me plus 2. Take away 3. That will mean I end up with 0. Okay, if I put 0 in, it's going to be 0 squared minus 2 lots of 0 minus 3, giving me minus 3 as an answer on that one. All right, I'm going to do a positive one just so you can see that. So if I put 1 in, 1 squared is 1, minus 2 times 1 is minus 2, and then minus 3 on the end of that one. That's going to make sure that I end up with negative 5. Sorry, negative 4 on that one. Okay, so negative 4 there. And if we were to do it for the others, you would end up with negative 3, 0, and 5. And then you want to be able to plot them. Okay, so this time when we're plotting it, minus 2 along and 5 high, minus 1 along and 0, 0 and minus 3. We then have 1 and minus 4, 2 and minus 3, 3 and 0, and 4 and 5. Okay, so again, I'm going to start down here just so I can get this nice smooth curve at the bottom. And go up, making sure that my line goes through all of my coordinates. Okay, and hopefully this time you can see the line of symmetry is not x equals 0 anymore. Okay, and the line of symmetry is actually going down through this line here. Okay, which again is crossing the x-axis, but it's crossing at 1. Okay, so my line of symmetry is the x equals 1 line, so this one going straight down here. Okay, my vertex on this one, so the turning point is again this point here, so that's going to be my 1 minus 4, so that's where it changes direction. Okay, we can also use the graphs to work out missing values. So if I ask you to work out what is the x value when y equals, let's go with 3, and you'll notice that when y is 3, okay, so this is on my y-axis, I go to 3, I've got a solution here and a solution here, and you have to just do the best you can in terms of reading off your x values. So I would say at that point it is x equals negative 1.5, and my other value is over here, so coming down here just below 4, so probably around 3.8. So they would be my two solutions, okay, at that point. So if you're asked a question like that, that's how you do it. Okay, so there's a worksheet for you to have a go at. Let me know if you've got any questions. It's worth making sure that you mark and check your coordinates are correct before you go through plotting all of the graphs. Remember, a nice smooth curve, use a pencil